The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today we're going to start chapter 9. Take a look at section 9.1, which is radical expressions and radical functions, roots as it were. So let's talk about the idea of a square root. Let's start by talking about the idea of a square. If we take the number 3 and we square it, we get 9. If we want to go back to the roots, well, what does roots mean? If the roots of something is like where you began, where you started, where you were born kind of thing. So if we want to go back to the roots of a square, we want to go back to the number that was squared. So the square root of 9 takes us back to 3 because 3 squared gives us 9. Okay. Now, that's a sad looking radical there. Let's see if I can write that a little better looking. Even though 3 squared equals 9 and -3 squared equals 9, when we take the square root of 9, we just get the positive root, which is known as the principal square root. Okay, now let's talk about the names of things. Let's look at the cube root of 8. So this symbol right there is called a radical. It is a grouping symbol, and it groups together the quantity inside, which is called the radicand. So the radicand is inside the radical. And finally, this number is called the index, which tells us which root we're going to take. In this case, the third root or the cube root. Now, the most common root is the square root. So that would be like this. The square root of 4 is 2. However, because the square root is the most common root taken, mathematicians decided we're not going to bother putting an index of a 2 when we take the square root. So when there's no index written, the index is an implied 2. So like the square root of 9 is 3, the square root of 25 is 5, etc. There's an implied index of a 2, but it doesn't need to be written. Again, it's just implied. Okay, now you can take the square root of 0. You can take the square root of a positive number and you get a positive answer. You can't take the square root of a negative number. That is not real. Also, when you take a square root, you can't get a negative answer. Okay, so you can't take the square root of a negative number. When you take the square root of a 0 or a positive number, you don't get an answer that's negative. This is not only true with just square roots, but any even root. So a 4th root, a 6th root, a 10th root. You can't take an even root of a negative number. And when you take an even root of 0 or a positive number, you can't get a negative answer. So there's all these restrictions, but they have to do with even roots. With odd roots, there aren't any of these restrictions. For instance, the cube root of 8 is 2, but the cube root of -8 is -2 because -2 times -2 times -2 is -8. So you can take an odd root of a negative number and you can get a negative answer when you're taking an odd root. The restrictions have to do with even roots. Okay, now let's see here. Let's take a look at some examples. It says evaluate each square root without using a calculator. So the square root of 100, we're looking for a number where that number squared or that number times itself is 100. So the square root of 100 is 10 because 10 squared or 10 times 10 equals 100. How about the square root of 49? Well, that would be 7 because 7 squared or 7 times 7 equals 49. How about the number negative the square root of 64? Now be careful. The radical sign, the square root symbol, if you will, is a grouping symbol. That negative sign is not inside, it's on the outside. So this would be the square root of 64, which is 8, and then the negative sign would come down, so we get negative 8. However, if we had this, this would be not a real number. So it's important as to where the location of that negative sign is. Okay. All right. Now, let's see here. How about the square root of a fraction? We can separate it into the square root of the numerator over the square root of the denominator, and we'll talk more about that in a later section. The square root of 4 is 2. The square root of 25 is 5. So the square root of 4/25 is 2/5. How about the square root of 0.16? Well, what times what? Let's see, 4 times 4 is 16, but we need it over 2 places. What if we wrote 0.4? Would 0.4 times 0.4 be 0.16? Yes, it would. Okay, here. Now we're going to use a calculator to find the square root of 12. So where are those square root keys? Well, on our calculator, and I've got the TI 30X Roman numeral 2 here. Over on the left column, there is a button that says x squared, and the second function key of that button is a square root button. So to do the square root of 12, I'm going to put in, let's see here, I'm going to go this, turn it on, second function key, push that x squared, so I'm going to end up getting that, the square root of with a parenthesis, a left-hand parentheses. Then I'll type in the number 12, close up the parentheses, push equals, and I get 3.4641011615, going on and on, but it said, let's see, where was it here? Use a calculator to find the square root, give each answer to 4 decimal places. So the 4th decimal place is that 1 right there. The 5th place is a 0, which remember 4 and below rounds down, 5 and above rounds up. So we're going to get 3.4641, rounding to the nearest or to 4 decimal places. All right, let's do one more of those. The square root of 0.0063. So again, second square root 0.0063, close it up, equals, and I get 0.079372539. 4 decimal places would be the 3, the 7 round, whoops, the 7 rounds up, so we get 0.0794. Okay, any questions about that?
No.
All right, now the following problems, it says this, it says simplify each expression, assume that all variables are unrestricted, meaning that the variables can represent any real number, a positive, a 0, or a negative real number, and use absolute value symbols when necessary. Okay, so let's say we've got the square root of 4x squared. Okay, the square root of 4 would be 2, and the square root of x squared would be x. Are you okay so far with that?
Yeah.
However, it said that x could be positive, or it could be 0, or it could be negative. Since we're taking an even root, our answer can't be negative. If x represented a negative number here, we'd be in trouble. So we have to come back and put absolute value bars around the x to make it 0 or positive, but in any event, non-negative. Now, you might say, well, what about in here? If x is negative, aren't we taking the square root of a negative number? No, because x squared would never be negative. As long as it was a real number, even a negative real number squared is going to give you a positive. So we're okay there. Now, what about this situation? The square root of 81h to the 4th power. The square root of 81 is 9. The square root of h to the 4th would be h squared. Do I need absolute value bars here? No, I don't, because even if h is negative, h squared in our answer would not be negative. So no absolute value bars needed there. What about this one? The square root of 36 s to the 6th power. Well, the square root of 36 is 6. The square root of s to the 6th would be s to the 3rd. Do I need absolute value bars here? Yes, I do. Again, we're taking an even root. And if s is negative, s cubed would still be negative, and we can't have a negative answer when we're taking an even root. And then finally, the square root of 144 m to the 8th. The square root of 144 is 12. The square root of m to the 8th is m to the 4th power. If m is negative, m raised to the 4th power would be positive. So we don't need any absolute value bars there. I would say, rather than trying to memorize each case by case, to just think each case through and say, okay, could this answer be positive or negative? If it can't be negative no matter what, you don't need absolute value bars. If it could be negative and we're taking an even root, then we have to protect it with absolute value bars. Okay, next we're going to graph a, graph a function. It says complete the table and graph a function. So let's go down, actually, let's go back up here. And we have the following: f of x equals the square root of x. And our table is going to look like this. We've got x and y, 0, 1, 4, 9, and 16. Okay, now f of 0 would be the square root of 0, which is 0. F of 1 would be the square root of 1, which is 1. F of 4 would be the square root of 4, which is 2. Whoops. F of 9 would be the square root of 9, which is 3. And f of 16 would be the square root of 16, which is 4. Notice that all the y values are nice integers. Why is that? Well, all of the x values are perfect squares. They have two identical factors. 0 is 0 times 0. 1 is 1 times 1. 4 is 2 times 2. 9 is 3 times 3. 16 is 4 times 4. If you take the square root of a perfect square, you get a nice answer. So the authors deliberately picked nice values, perfect square values of x to get nice values of y. Now, graphing these points, we have 0, 0, 1, 1, 4, 2. Let's see, 9, 3. If this is 5, 6, 7, we'll extend this out a little ways, 8, 9. So we're right about there. And the 16, 4 is not going to make it on this graph. So I've got this picture. It's going to have an arrow to the right, but it's going to stop at the left. Okay, why is that? Well, If we pick an x value less than 0 and we take the square root of it, we don't get a real answer. So the domain has to start at 0. Okay. Now, x can get larger and larger positive, which is why there's an arrow to the right. So the domain goes from 0 up to positive infinity. The range, the y values, again, since we're taking an even root, we can't get negative answers, but our starting range value is 0, and that also goes up to positive infinity. So we get that scenario. Any questions about this particular graph?
No, I think I got it.
All right, let's take a look at another example. And let's go to this one. And let's see, we have f of x equals the square root of x plus 4. Okay, now here they don't give us starting values of a table. So let's see what's going to happen here. Okay. Well, if we use the same values as we did before, 0, 1, 4, 9, and 16, let's see what's going to happen. Keep in mind in the last example, we were taking the square root of just x. Now we've got the square root of x plus 4. So x plus 4 is the radicand, okay? Well, if x is 0, f of 0 would be the square root of 0 plus 4, which is the square root of 4, which is what? 2. If x is 1, f of 1 would be the square root of 1 plus 4, which is the square root of 5, which is, oh, that's not very nice, is it? So by adding that plus 4, it kind of messed things up in there, didn't it? Well, let's take a different approach to this thing. If I want to have nice outputs, let's do it this way. Let's try to get the same outputs we had before, which was 0, 1, 2, 3, and 4, I think was what we had, yeah. Since once I put x in, the next thing I'm going to do is add 4 to it. My x values could be smaller than these way back there. Smaller by how much? They could be 4 smaller because the first thing we do when we put it in the radical is add 4. So 0 minus 4, 1 minus 4, 4 minus 4, 9 minus 4, 16 minus 4. You follow what I'm getting at? Let's see. 0 minus 4 is negative 4. 1 minus 4 is negative 3. 4 minus 4 is 0. 9 minus 4 is 5. And 16 minus 4 is 12. So what did I do? I took these original x values and I subtracted 4, because now what am I going to do when I put that in there? I'm going to add 4. So what's f of negative 4? Well, that would be the square root of negative 4 plus 4, which is the square root of 0, which is 0. If I put in negative 3, f of negative 3 is going to be the square root of negative 3 plus 4, which is the square root of 1, which is 1. You see what's happening there?
Yeah, that makes a lot of sense.
Okay, so x is negative 4, y is 0, x is negative 3, y is 1, x is 0, y is 2, x is 5, y is 3, and we'll skip that one. So now my graph looks like this. So the domain is what? Negative 4 to infinity, and the range is still 0 to infinity. Now, wait, I thought you couldn't take the square root of a negative number. We aren't. The whole thing isn't x. The domain is just the x piece. So we're taking an x, adding 4 to it, and then taking the square root. So we can go all the way back down to negative 4. In fact, notice this original graph compared to the new one. This graph has been shifted to the left 4 units. And we'll talk more about that in a later chapter. All right, now let's take a look at, let's see here. Here. it says find the domain of each function. So we're no longer going to graph it. We're just going to find the domain. Keep in mind, we can't take an even root of a negative number. So that means that the radicand can't be negative. So it either has to be greater than 0, which would make it positive, or equal to 0, which would make it 0. You can take an even root of a positive number or 0. So if we take the radicand and set it greater than or equal to 0, and then we go in and we solve this inequality, we get the domain of the function. X is greater than or equal to -6. So because it says equal to, we include it, and then up to positive infinity. You okay with that example?
Yeah.
All right, let's take a look at another one. H of x equals the square root of 35 minus 5x. So that means 35 minus 5x has to be greater than or equal to 0. Okay, I'm going to subtract 35 from both sides of the inequality. -5x greater than or equal to -35. Then I'm going to divide both sides by -5. What happens when you multiply or divide both sides of an inequality by a negative number? What do?
You flip the symbol.
Yeah, change the direction of the inequality symbol. So now our domain is going to be, oops, wrong symbol there, from -infinity up to and including 7, just like that. Okay. Next, it says, find each function value. Do not use a calculator. So we've got f of x equals the square root of 3x plus 1. We are to find f of 8 and f of -2. So f of 8 would be the square root of 3 times 8 plus 1, which is the square root of 24 plus 1, which is the square root of 25, which is 5. F of -2 would be the square root of 3 times -2 plus 1, which is the square root of -6 plus 1, which is the square root of -5, which is not real. Now the author says undefined, but I don't agree with that. I think it should say not real, okay? Because undefined typically means you're dividing by 0. But anyway, moving on with that. Here it says, use a calculator to find each function value, round to the nearest 10,000th. So f of x equals the square root of the quantity x squared plus 1. We're to find f of 4 and f of 2.35. All right. So f of 4 is going to be the square root of 4 squared plus 1, which is the square root of 16 plus 1, which is the square root of 17. So second square root 17, close it up, and I get 4.123105626, and then the calculator's, it doesn't have any room for the rest of it there, but we're supposed to round it to the nearest 10,000th, 100,000, no, what is this, 10th, 100,000th, 10,000th. So there, 4 and below rounds down, 5 and above rounds up. So we're going to get 4.1231. And then this one over here, that would be, let's see, the square root of 2.35 squared plus 1, which is the square root of, let's see, 2.35 squared. It's 5.5225 plus 1, which is the square root of 6.5225. So we've got the square root of 6.5225. which comes out 2.553918, etc. We're going over to the 10,000th. The one would round down, so 2.5539. Now, I went through and I calculated each little piece. I could have just put this original statement into the calculator, second square root, and then put in parentheses 2.35 squared plus 1 close parentheses equals. I didn't have to do each separate piece is what I'm saying. Okay, so we've been dealing with square roots. Let's take a look at some other roots. How about the cube root of 1? Well, that's 1 because 1 times 1 times 1, or 1 cubed equals 1. How about the cube root of 8? Let's write that a little nicer. The cube root of 8 is 2 because 2 times 2 times 2, or 2 cubed, equals 8. How about the cube root of negative 27? Well, that would be negative 3. Oh, how can we take the root of a negative number? Because it's not a square root or an even root, it's an odd root. So we can get a negative answer. Let's say we're taking the cube root of a fraction. So that's the cube root of 125 over the cube root of 64. The cube root of 125 is 5. The cube root of 64 is 4. Okay. Let's see. Okay, now we're going to look at some other graphs, and hopefully this program will work nicely. I tested it earlier and it worked fine, but I had the same thing another day where I tested it and it gave me issues. So we'll see what happens. Here we go. All right. It says complete each table and graph the function. It says f of x equals the cube root of x minus 3. X and y, negative 8, negative 1, 0, 1, and 8. First of all, I want to point out the minus 3 is not inside the radical. So we're going to pick an x, take its cube root, bring that out, and then subtract 3. Notice that the x values that the author chose are all cubes. Since we're taking a cube root, the cube root of a cube will be nice. So f of negative 8 is the cube root of negative 8 minus 3, which is negative 2 minus 3, or negative 5. Are we okay with that?
Yes.
Okay. F of negative 1 is the cube root of negative 1 minus 3. The cube root of negative 1 is negative 1, and negative 1 minus 3 is negative 4. If x is 0, f of 0 equals the cube root of 0 minus 3. The cube root of 0 is 0, and 0 minus 3 is negative 3. F of 1 would be the cube root of 1 minus 3. The cube root of 1 is 1, and 1 minus 3 is negative 2. F of 8 is the cube root of 8 minus 3. The cube root of 8 is 2. 2 minus 3 is negative 1. Okay, so let's label the scale here. Negative 8, negative 5 is right there. Negative 1, negative 4 is there. 0, negative 3 is there. 1, negative 2, and 8, negative 1. And so I get a graph that looks like this. And it continues on in both directions, to the left and to the right, and as well as up and down. So the domain of this would be all real numbers, and the range would also be all real numbers. Okay. Any questions about this one?
Nope, I think I got it.
All right, let's go on to another function. It says graph each function, give the domain and range. And here we've got f of x equals the cube root. The cube root of x minus 3. Okay. Now, earlier on in this section, I graphed the square root of x. And then I graphed the square root of, I can't remember what it was, x plus 4 or x plus 6 or something like that. And it caused us to shift things around. Same thing here. I would like to put in, let's go back to the previous one here. I'd like the results of what's inside of here to be perfect cubes. Here, all that's inside is x. So if x is a perfect cube, we put it in, we get a nice number. But here, we're going to take x and then subtract 3 from it, and then take the cube root. So we want to take these values and add 3 to them, so that when we put them in here and subtract 3, we get perfect cubes. Does that make sense? Well, my voice is cracking up.
Yeah, it makes sense.
So I'm going to add 3 to all of those. So -8 plus 3 would be -5. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 8 plus 3 is 11. Okay. So I took -8, -1, 0, 1, and 8, and then I added 3, so that when I put them inside there, subtract the 3, then take the cube root, I get nice numbers, as we shall see here. So f of -5 is the cube root of -5 minus 3, which is the cube root of -8, which is -2. F of 2 is the cube root of 2 minus 3, which is the cube root of -1, which is -1. So see how I'm getting the same y values. Oh, wrong one. Well, okay, because this had a -3, so forget that. Forget that thing I was going to say. Okay. F of 3 equals the cube root of 3 minus 3, which is the cube root of 0, which is 0. F of 4 is the cube root of 4 minus 3, which is the cube root of 1, which is 1. And f of 11 is the cube root of 11 minus 3, which is the cube root of 8, which is 2. Okay, so -5, -2, 2, -1, 3, 0, 4, 1, and 11. Let's see, 6, 7, 8, 9, 10, 11. 2 is right there. So our graph looks like that. Domain and range, all real numbers. Okay. How does this graph compare to, well, no, I can't, I didn't graph just the square root of cube root of x, so forget that again. Okay. Let's see here. Let's take a look at some more just evaluations. So I'm going to get rid of that. I'm going to go back here to this. It says evaluate each radical expression, if possible, without using a calculator. So we've got the 6th root of 64. So the question is, what times itself times itself times itself times itself times itself is 64? Well, 1 times 1 times 1 times 1 times 1. See, I don't know if I had enough there. 1 times 1 times 1 times 1 times 1 times 1 would be 1. So it can't be 1. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Aha. So 2 to the 6th power is 64. So the 6th root of 64 is 2, just like the 6th root of 2 to the 6th would be 2. It's almost as if though the index and the exponent get rid of each other. In fact, they do, but we'll talk more about that tomorrow. I know everything's always tomorrow, tomorrow, tomorrow. All right, what about, let's see here. Negative the 4th root of 625. The negative sign is outside, so we're not taking an even root of a negative number. Well, the 4th root of 625 is 5, and then the negative sign comes down, so we get negative 5. What about the 4th root of negative 625? That is not real, because you can't take an even root of a negative number and get a real answer. Okay, what about this? The directions say, assume all variables are unrestricted. They can be positive, negative, or 0. How about the 5th root of 32, a to the 5th? Well, the 5th root of 32 is 2. The 5th root of a to the 5th is a. Do I need absolute value bars? No, I don't. Since I'm taking an odd root, there's no restrictions. What about this one? The 6th root of 64, b to the 6th. Well, the 6th root of 64 is 2, and the 6th root of b to the 6th is b. But I do need absolute value bars here because I'm taking an even root, and b could be negative or positive, so I need to make sure it's not ultimately negative. Okay. Here, some lookalikes. A, B, C, and D. The square root of 64, the cube root of 64, the square root of negative 64, and the cube root of negative 64. All right, the square root of 64 is 8. The cube root of 64 is 4. 4 times 4 is 16, times 4 is 64. The square root of negative 64 is not real, but the cube root of negative 64 is real. Recall, you can take an odd root of a negative number, so you've got to be careful. So those two big things in this chapter so far: you can't take an even root of a negative number, and when you do take an even root of a number, you can't get a negative answer. All right, well, that's all I have for you today. So I am going to go ahead and stop the recording. I'll be back at 1:15 this afternoon with an office hour.